All right, welcome back to 105. So we're done all the content for the midterm. Yay, we're a week ahead of other people, so good. I guess that's good. So today we'll be doing some more practice. We'll be solving a larger program, and then next week we can do all midterm review, so we get a lot of practice, and we can all do very, very good on the midterm. So we'll have like 3 lectures to go through it. So again, use the Discord, post questions, go through the old exams, look at them, the old midterms. Let me know if there's anything in particular you want me to pay special attention to. Otherwise, we'll just go through them in reverse chronological order, and we will figure it out from there. But we can breathe a sigh of relief now. So, as a detour, let's try and write a bigger program. So there's this thing called the Goldbach conjecture, and some very, very smarter than me person, like over 280 years ago, apparently just came up with this, and he just said, for every even integer greater than 2, it is the sum of 2 prime numbers. And this is still, to this day, unproven. It seems to be true. People have tested it up to very, very, very large numbers that it is true, but no one can actually prove that is indeed true. But today we'll write a program to see if it actually holds and actually be able to go ahead and test this conjecture that has not been proven. So we are starting from absolute scratch. So nothing here, there's just an empty main, returns exit success, doesn't do anything. So this is a very daunting position to be into because, well, I don't know where to start. So given this problem, anyone want to tell me where I should start? What is the first thing I should think about if I want to write a program that will go ahead and test this for us? Yeah?
Maybe like how to find a prime number.
Yeah, maybe how to find a prime number. I also should probably be concerned about getting some input from the user. Maybe I want to verify that I can actually get the input. What about in terms of solving the problem? Well, the easiest thing to do is just not even worry about how to program this in C. Just think about how I would solve it if I was on paper, because basically programming is the art of explaining all of the steps to solve the problem to a very, very stupid machine. So computers, really dumb. You have to guide them through solving all of this. So sometimes it's nice just to write it out by hand. So if I were to do this by hand, how would I prove this conjecture is true? So just so we have it, let us just write. So every even integer greater than 2 is the all right, so given that conjecture, if I just give you just some number, so let's say an even number greater than 2. So let's say I give you the number, I don't know, 44. How would you come up with proving that this is true, or at least that it holds, not prove, because then you'd be smarter than 300 years collectively of humans, but showing me that for 44, this conjecture does hold. Yeah.
I guess first you can make sure that it's an even number, 44.
Yeah, so 44, it is an even number. It is greater than 2, so this is a valid input. So after I have the number 44, how should I see if this conjecture does hold or not? Yeah.
Then you could just subtract 1 and then see if that remaining number is prime as well.
So for this, 1 is not a prime number.
You do a 3 then, when you try 3.
So try 3? So I try 3. How do I try 3?
You get 44, you subtract 3.
Okay, so,
See if that remaining number is also a prime number.
so the other number is like 44 minus 3, so 41. So I could try that and then see if they are both prime numbers. So how did you come up with 3?
It's the first, like, prime number.
Uh,
You could use, like,
for-
first prime number, like, not 2 that you could use.
Why wouldn't I be able to use 2?
Because if you add 2, you would have to use another even number to get to 44, which isn't prime.
So I will counter that. So that's a good thought of like, okay, well, if I start with 2, then if I minus the other number, well, it'll be even, and that will not be a prime number. What about if my input is simply 4?
Oh, wait, yeah. It gives you 2 and 2, okay.
Yeah, so you're being a bit too clever already. So always good just to start with the first prime number. So maybe I should check that, or maybe that's not 2. But you know, in this case, yeah, if I did 2 plus 42, that's not it, so I can just cross it off the list. Then I just go to the next one, 3 plus 41. Oh, they both happen to be prime. But what would I do if this was not actually the sum of 2 primes? What would be my next step if for some reason that was not true?
You could keep iterating, so like you could try the next
Yes.
number, which is like 5.
Yeah, so I could try 5, which is the next prime number. So when we're solving this and we have to explain it or like write it in C, should any of the terms we use that like we take the number and we get another number certainly sounds like a function. If we can give a name to an input and an output, probably gives us an idea of something we should write. So you said, if that wasn't true, I should go to the next prime number and then subtract it. So I probably need a function called next prime, which would probably take an integer and return an integer. All right, so that's good. We're already breaking the problem up into steps. What other function would be useful? So what did I say? So I took 40, so like I would take 3, then figure out, okay, the other number is 42. What did I ask about 42? If it was prime, right? So maybe I need a function called bool is prime. And then, other than that, this is good enough to get me going. I can kind of see it, so I can ask for some number. So let's say I just ask the user for some input, and all I get is a single integer. So it might be nice to just write your function like this because I don't need any, whoops. And this needs an int, sorry. So don't need any input to the function. I'll just ask the user to input a number and make sure it holds true. And well, I don't have to deal with pointers because I'm just returning a single value. So I should probably just use a function. So with that, that seems to be enough to get going. So let us turn to C. So first function we should probably write is the user input one, user input. Oops. So we're returning an int, and we don't need any arguments. So if I want the user to input a number so I can test it, I should probably tell them what they have to input, right? So let's say enter integer greater than 2, and it's an even integer. And then I have to do scanf. Oh, okay, it needs to be an integer, so it's a %d format specifier. Oh, okay, right, I need to give it a variable, so let's just call it input. I'll just initialize it to 0 just to be safe. In this case, it doesn't matter. And then scanf, so now through that pointer, it goes ahead and sets that value for me. That matches the user input. And then I just return that input. And in the main, I'll use it. So I'll just say num equals user input. All right, is that a good user input function? Looks good? All right, let's see it. So usually when we test our program, we assume the worst case that our user is an absolute jerk. So if I go ahead and run this, enter an even number greater than 2. Sure thing. Should probably do something a bit better than that. How would we do something a bit better than this? Yeah.
We have a while loop that runs while the user doesn't input something that's greater than 2.
Yeah, okay, so maybe have a while loop that doesn't let the user input something that's not greater than 2. So while the input is what? So while the input is what? Less than or equal to 2? So while the input is less than or equal to 2, maybe I cost the user a little bit. All right, maybe I do something like that. And maybe if you want to be clever, the more times the user gets it wrong, the meaner you get. So that could be an extension to our program. We'll just be a little bit of a jerk for now. So let's see. We enter 1, we get hey jerk, enter a number greater than 2. We say 2, tells us we're a jerk again. Okay, 3. Was that an even number? All right, what else do I have to put on here? Yeah. Or if it's odd.
And you have to check how that's odd. So you can use mod to probably have that as a separate line. Because input mod 2 does not equal 0.
Does not equal 0. Like that? Maybe, okay. So looking at that, so that should continue asking the user if they enter something that is less than or equal to 2, or it's not an even number, right? Either one of those that fails, so this should do the trick. So let's say I enter a 1, okay, I enter a 0, okay, no. Enter a 2, no, okay, 3, 5, seems to not let me enter an even number, and then, some number greater than 2 that is even, 10. So that seems to be good for our user input. Any thoughts about that, or does that seem good now? Seems relatively decent. All right, so what are the other ones? So maybe we want to just write all the function prototypes we thought of up here. So we had this one, we had next prime, and then we had is prime, bool is prime. And then we used a bool, so we need this. And let's move this to the end, just for argument's sake. All right, which one should we write next? If it's prime? Okay, so let's write bool is prime. Int, we'll just be clever and call it an x. So how do we know if a number is prime or not? Yeah, so if it's prime, it's only divisible by 1 and itself, right? So if it's divisible by any number between 2 and less than itself, then it is not a prime number. So what would that look like? So what should I write here if I have to write it in C? Yeah.
I mean, first you could check if the number is even.
First I could check if the number is even, yes.
Even, then it can't be prime, so no.
So if the number is even, then it is not prime.
Well, our input is not going to be, like the input's going to be an even integer greater than 2, so you don't have to consider if it's 2.
Oh, I had a question also in Discord. If I enter A or nothing or a large number, we're assuming that the user inputs at least an integer for this course because, like I said before, scanf's hard to use. So it doesn't actually do good. So this starts us off, so like this, if the number is divisible by 2, then it's not a prime number, unless it is 2. And if I kept going with this, in general, it's like up to how big the number is, right? So it would have to be like, well, if the number is divisible by 3, then it's not prime. If the number is divisible by, well, 4 maybe, then it's not prime, although I could skip that one because it's not prime. And yeah, this looks like loop territory, right? Every time through, I'm going up by 1. And for the sake of this course, like, sure, if I don't really have, well, actually I would have to check if it's divisible by 4. But we have this pesky situation where I shouldn't do this for the number 2 because the rule is you're prime if you can't divide by like more than 1 and yourself. Right? So 2 is itself, so that doesn't count. So probably there's like a bound what number I should go up to here, right? So I shouldn't go up to myself. And I should also start at 2. So if I should start at 2, and this number, so this is like x divided by something, right? All right, if I want to give the something a good name, if you do like number divided by something, what's the and something actually called? Anyone remember their math? The divisor? Yeah, well, we'll call it the divisor. All right. So, yeah, we can do a loop, divisor. So we can start it at 2 maybe. So we start at 2, doing it by 1, pretty useless. So we can go let the divisor go up till less than x, because that's our input. So if my input is, let's say, 2, it wouldn't try and divide it by 2. It would stop before that, and guess what? It wouldn't even try anything. So we would do plus plus divisor, and then we can kind of move this in. So instead of checking if x is divisible by just some number, we can do if it's divisible by the divisor. And then here we have a few choices of what to do. So if we find that it is not, like if this is divisible, so it's a factor, and we know for sure, if we go inside this if statement, we know for sure that it is not a prime number. So 2 strategies here. Maybe I just have a Boolean that I keep track of if it's prime or not, and then I set it equal to false. But usually the good thing to do in functions is if you already know the output of it, you can do a return, and it will just immediately end that function, and it wouldn't even trying to divide anything else. So I can just immediately return false. And then function's done, wouldn't have to try anything. I know it is not a prime number. All right, anything else with this function? Sorry, return true at the end?
Like, well, if the thing is prime, then what happens?
So if the thing is prime, then
You
it,
have it to return false, but then you have to return true, like if it's prime. So that, like you have to work on that too.
yeah, so I have to return true if it is prime. So how do I know it's prime here? Yeah,
That's a whole question. So for the int x here, is x the user input or
so,
other prime number we want to find?
so x can just be any integer. So we're just assuming it can be anything right now because we're writing just this function, just as a little helper function because we know we need to ask, hey, is some number prime or not? Yeah,
To answer your question, you can place a return true at the very end, and you know that if it reaches that point, that means the for loop's if statement never executed. So if it's not prime, then it is prime.
yeah, exactly. So if I go through this entire for loop and I never go into this if statement, so it never returns anything, and eventually I've tested literally every single divisor and it's not divisible, so at the end of this for loop, we know for sure that, well, it wasn't divisible by anything that was 2 or less than itself, so it must only be divisible by 1 in itself. So we can just immediately return true, and we're all good. So just to test it, yeah?
Do you have to return true, or is it like you cannot use beginning mode with if it's true?
So we do have to return true in this case because if you just leave it out and you compile it, C will say something like non-void function does not return a value in all control paths, which basically just means it's possible for this function that returns a value to end without you calling return. And for the purposes of this course, there is usually it returns 0, so usually the default value it returns is a 0, which is not what we want. We want to say if it makes it to the end, it's true. So, but that's a new error. I don't think we have seen that one yet. Well, it's a warning, so it still compiles. The compiler will do something, but it would have been a complete pain to debug. So now we can go ahead, see, okay, I'm a jerk. How about 4? Okay, I can enter that. So maybe we test in our program. Let's just see what the result is of just making sure that it is prime works. So we can do is prime 2. Let's make sure that we can say that 2 is an even number, or a prime number. So it doesn't matter what input I give it, and it says, yep, it's prime. So that's good. Maybe when we test it, we don't care about the user input. So maybe we try a bunch of values. So 1 is technically not prime. So, oh, whoops, we screwed that up. So maybe we have to fix that because that's kind of a bit of an edge case where I even think they considered 1 as a prime number before, but then they changed their minds. I don't know, math people are weird. So we can just make sure that if x equals 1, we can just special case that. We'll just say it's not prime. And that's fine. And we'll assume that this works for integers 1 or greater. So we won't bother to deal with negative values because it has slightly weirder rules. And yeah, we just won't bother, won't test it, and doesn't really matter because our input are going to be always positive. So don't have to deal with negatives. All right. So now we got some user input and a prime function. So how did we say, oh wait, we need another function. We need next prime. Okay, so we need next prime. All right, how do I go about next prime? So my x is just going to be some integer that I assume is prime, and I should give you the next prime number.
We can use the
Yeah, so I could probably use next, or is prime, so how would I use is prime? So we can think of it in little steps, yeah?
Maybe just increment x and then check if it's prime and keep doing that over and over again.
Yeah, well, we can just check, right? If we had to like, computers are basically like just really, really stupid things that can do stupid things really fast. So if it works, it works. So for next prime, what we could do is just take the number, add 1 to it, and see if it's prime. If it's prime, great. If it's not prime, do it again. Okay, and if we try it, we increment it again, and it's prime, great. If it's not, we do it again. So if I was to translate what I just said into code, how would we do that? Yeah. Yeah, a loop. What kind of a loop? For loop? So if we do a for loop, we have to know where to start. So where would I start with a for loop? Hmm?
Is x the same value like we had before? Is it the same?
So we're assuming x is just some random number we get. All we can assume is that it's probably prime. In I equals x? Or like that, we start with x? I guess we can. So remember, we should use for loops when we like know how many times we do something. So in this particular problem, do we know how many times we're going to say, oh, this one's not prime. This one's not prime. No. So for loop, what's our other option? While loop. So there's also like a do while and a while. So in this case, well, let's think about each time we need to go through it. We just said we increment x, right? Yeah.
Like if you have a for loop and then like for checking whether you should continue, have like is not prime, like use that.
Oh, so we're going back to the for loop. So you want a for loop? All right, so if we want a for loop in I, so what's it start at?
Let's just say
X plus 1. Okay, and the condition you want is just that x.
I is not prime.
So,
I not
so you want I is not prime, which is like,
not is prime.
uh-huh. And then how much, and how far do I go up?
Plus I.
Plus I? Like,
Or I meant like you just keep going and then the condition to exit the loop is if it is prime.
so you don't want me to write anything here?
I guess.
Because this is like normally where I do like plus plus.
Yeah, sure.
Okay, so that. All right, so if I do this, then how do I know when it stopped? And what's the next prime number in this case? So x? So x we didn't actually change. So, and like if I do, you might be thinking, I can kind of see where you're going here. Like at the end of that for loop, I is a prime number, right?
Yeah.
So I can do return I, get a red line. Error. Can you fix that? Yeah, so the I is only in scope between these brackets. Other than that, we can't access it. In this case, yeah, if we want to, we could just do int I over here and then get rid of this. So now I is in scope even after that. So I create I immediately, and it is in scope for the duration of the function. So I could do something like that. So seems like that's a good solution. Let's see. So we can test it by printing a few results. So let's say an next prime of some number equals some number. So let's say next prime of 3. All right, so what is the next prime of 3? Do we actually know the result of, or what that should be? 5, right? So let's see if we get a 5. Whoops, I did not comment. Not you. Yeah, 5. So seems to work. So the only slight comment I would have to this is like a for loop with nothing in it is a bit strange. So like just converting it to its loop equivalent might be a bit cleaner. And we could also, like, we get a copy of x, so we can just modify that. We don't actually have to create another variable. We can just change x if we want. So we could do something like plus plus x and then check if that's prime. So we always do that. So if we always have to do an operation no matter what, we can do a do while loop. So we could just like do plus plus x while not, wow, I can't type, not is prime x. And then we can return x. But mean the same thing. Oh, I can get rid of this. So mean the same thing. Some people pride themselves in using as little variables as possible, but means the same thing. Last one, perfectly acceptable, but some people might find this a bit easier to read. Again, some things are up to taste. Usually people don't like when for loops have nothing in them, but like we saw, a for loop is basically just a fancy while loop. All right, so now we're looking pretty decent. So how would we test this now? So remember so this we probably have to go back. And when we did it by hand, right, we started with 2, and then we took that and we subtracted whatever the number was, and then checked if the result of our subtraction was prime, and then if it was prime, then we're good, we're done. So we can do the same thing here. So let's go back. So we can pick a first number. 2 was our first number because that's the first prime. And our second, well, that would be num minus the first. And then I could go ahead and just iterate on this a few times. I don't know when I have to stop asking about when a prime number is, but we can just kind of see. So we can write the body first of like what we have to do every single repetition. So all we have to do is check is like if the second, if is prime second, then we're done. And then if that's not true, then we have to, go through it over and over again. And kind of seems like we're also doing another Boolean, and it's kind of messy if we have to like just finish this loop or break out of it. So that might tell us that, oh, we should probably just write another function. So like bool conjecture holds for some x. So let's start writing that. So we'll just take our input or our solution and put it there. So maybe we have here if conjecture holds num and then if it's false, we can just say else if it doesn't hold, then we win like millions of dollars. We broke math. Cool. All right, so I called this num. All right, so if the second number is prime, right, we can just say the conjecture does hold. We can return true. Otherwise, well, what we just do is the first number, when we did this, just goes to the next prime, right? So if I were to say that, I update first to be the next prime of first, right? Something like that. So if the input, if my first is 2, then I get a 3 out of it. If it's a 3, then I get a 5. Then 5 is 7, and then after 7 is 11. Oh no, that's like my limit. And then here I would have to go ahead and recalculate second. So second is equal to num minus first. All right, and then kind of like looking for primes, we should probably figure out when we should stop this. So if we do this, let's say we have to go on and on and on. So we get up to like, say we get up to the number 22, and then we do like 22 plus 22. So if we get up to that, there's no use going to the next prime number because, well, I would have already done it on this side. So I can stop as soon as these numbers are like equal to each other, or they're at least, this number should always be smaller than this number. Otherwise, I'm going the other order. So I can just say that while first is less than or equal to second, then I do all this. And then if I go through that and I run out of numbers, then I know that this whole thing is false and we broke math. So that seem reasonable? Yep.
Is equal to included, first and second?
Yeah, so equals to is included in this case. So the first case that we would probably want to check is make sure this works for 4, because 4 holds because it's 2 plus 2, right? So let's go ahead and run that. So 4 holds. All right, and then we can try it with, let's try it with 45. Oh, I can't do that, right, jerk. All right, 46 holds. We can do, I don't know, 60 holds. Seems to hold. And then last thing to do, maybe I just like super functionize this whole thing and be like, okay, well, this kind of looks like a logical thing where like I'm just like outputting information about the conjecture. So maybe I just like do a void conjecture output. Wow, why can't I type? Put is not a thing. So maybe I make this a function. Maybe I have it overkill, where I just move it in. And then conjecture output of num. All right, so now my main looks like super simple, right? Take the input, give it an output. It's kind of one of our goals to make our make our functions just do one thing, and then whenever we read the code, it becomes a lot easier to read, right? I can kind of understand, okay, I take a number and then I give an output. Can't really get much simpler than that. So 44 holds. All right, let us make this better. So looking at this program, if I just give you like some giant number, so say I give you that and say it holds, wouldn't it be more interesting if I like said what numbers that was true? All right, so if we want to make this program better and say what numbers did this actually apply for? Like what numbers did I find that are both prime that sum together to give the original number? How would I do that? So the function where I figured it out was this conjecture holds one, right? So I already figured out the first and second, but this function already gives a value that I'm using as part of my logic, and I kind of want to like output three things, right? I kind of want to output whether it holds or not, and then what the first number is and what the second number is. So how would I do that? I want to like return three things. Yeah, pointers. This is one. Oh shit. It's like scanf, right? Scanf can use multiple values. If you need to give multiple outputs, then you have to use pointers. So we can say, okay, well, we need to use pointers, so we can say a pointer to int called first, pointer to int called second, and then these are the things that I'm going to change so the user can get that as input. So we have to change a few things around. So my argument for that becomes this, and then here. Okay, well, I need to create variables here so that I can essentially get their inputs or let this function, this conjecture holds function, actually update the values for me. So maybe I just do int first equals 0, int second equals 0. I'll just initialize them to something just so I feel better about myself. And now this looks like scanf where I have to give it the pointer to that integer. So I'll give it the pointer to first and the pointer to second. So luckily for us, the compiler helps us out a bit here because, well, we declared them before because we needed two integers, but now we're being supplied two integers that we get to update. So we can get rid of the declaration, but here we do need to set them. So how would I change this to, so if I just delete the int, is that all I need to do? So first is a pointer, right? So if I say first equals to 2, what does that mean? So that means first, like a pointer is just an address, right? So I say first is address 2. Is that likely to be good? Probably not. So what do I need to do to actually update the value that first points to? Yeah. Yeah, I have to dereference it first. And to dereference it, all I have to do is put a star. And then that little underline that the compiler was telling me that I'm silly goes away. So if you see that little yellow underline or compiler warnings when you compile, well, then you should just get rid of it. So turns out, before when I wrote this, each time I used first and second, they were integers. Now they're pointers. So anytime I see first and second, I should just dereference it first because I'm still just using integer values. If I dereference it, well, it's still an integer value. So I'll just go ahead and change all of them, which is fun. So I'll just put an ampersand in front of all of them, and including these ones. Whoops. And including this one. All right, and now all my compiler warnings went away. So now if I compile it, no warnings. Thankfully, I didn't miss them all. Hopefully, C would give me some help if I missed one. But in this case, it doesn't look like I did. So now if I wanted to print off the two values that that function set, what do I do in this print statement? So I can just say the numbers are D and D. So what's the first number called? Is it first? Is it star first? Is it ampersand first? Just first, right? So that was the actual integer. I gave this function the address of that integer, and it just constantly updated the value. And well, whenever it returned, first was a prime number, and also second was a prime number. So here I can just simply say first and second. So now, whoops. So now my program looks a bit more interesting. So yeah, cool. And because I wrote this one way, too, I can actually test it a lot of times. So now, let's say I wanted to just test it a whole bunch of times, and I wanted to see, hey, does this hold for the numbers up to, I don't know, 10,000 or something like that? That turns out to be easy, because I can just do like 4 in x, I don't know, so the first valid number was an even number greater than 2, right? So it was 4. Say I go all the way up to x equals, or x is less than 1,000, sure. And then, well, I could do plus plus x here, but that's not part of the conjecture because it's every even number, so I could just do x plus equals 2 instead. So each time through, instead of incrementing it by 1, I increment it by 2, so I just go to the next even number. And here, I can just go ahead and say, print off the conjecture output, and then I don't need any user input, so I can just test numbers up to, and let's say including 1,000. So if I run that, boom, I can look through it. Maybe I want to also print off in here what my original number is. It holds for D, and that would be called X. So maybe I do that so I can actually verify it. So it holds for 1,000, numbers are 3 and 997. I can scroll all the way up and see that seems like we haven't broken math, and it has figured it out. There's some weird patterns that math people probably love explaining. Ooh, there's a cool one. It goes up to 31. Wow. But see, we can go all the way up. We didn't see we broke anything. Whoops. And makes it easy, right? We wrote in a function. Testing it up to like thousands was easy. If I want to test more numbers, I can just increase that number until, you know, my computer takes too long to actually do it. All right. Whew, that was a whirlwind. All right, any questions about that? All right, cool. We developed a whole program together that's probably bigger than your next lab, and we did it in an hour. And I didn't actually really do that much except type, and I typoed most things. So you can do it faster, maybe. Yeah, and then again, so ask on Discord if there's any particular midterm questions you want me to go over. We'll be doing midterm practice all next week, so we can all do super well in the midterm. All right, so just remember, pulling for you, we're all in this together.